I wanted to go over number 15 and 16 on the review assignment, because I know a lot of you guys are struggling with it. So we'll look at 15 first. 15a, these are all solving. It gives you this quadratic, and when you see the quadratic, you want to make everything equal to 0. And we also want to write everything in terms of sign, because we already have what's there. So we're going to go ahead and we'll rewrite sine squared x minus sine x. And based on the Pythagorean identity, we know that cosine squared x is equal to 1 minus sine squared x. From here, let's get everything equal to 0. So we'll move this to the other side, minus 1 plus sine squared of x. This cancels. 2 sine squared of x minus sine of x minus 1 is equal to 0. You can use u substitution. Replace sine of x with u, so we get 2u squared minus u minus 1 equals 0. Now you get to factor. We're back to Frank's class. This would be 2u and u, and this would be minus 1 plus 1. Split it up. 2u plus 1 equals 0. U minus 1 equals 0. U will end up equaling negative 1/2 and 1. We're not solving for u, we're solving for sine. So, where is sine of x negative 1/2? And where is sine of x equal to 1? We know this is true. Our y value is negative 1/2. That's going to be 7 pi over 6. And what, 11 pi over 6? And our y value is 1. That will be pi over 2. The domain is just 0 to 2 pi, so we're done with that. I can go over b with you. Here's b. Tangent of x, cosine of x equals cosine of x. Oops. Always rewrite in terms of sine and cosine to help you out. And it's going to come out nice. These cancel, so now we have sine of x is equal to cosine of x. In other words, where is our y equal to our x coordinate? 2 places, quadrant 1 and quadrant 3, because that's where tangent's going to be positive, so it's going to be at pi over 4 and 5 pi over 4. If you think about the coordinates there, rad 2 over 2, rad 2 over 2, and negative rad 2 over 2, negative rad 2 over 2. Alright, that's B. We can look at C. C is sine squared of x plus cosine of x plus 1 equals 0. Same thing on this one. Rewrite in terms of, rewrite everything in terms of cosine. 1 minus cosine squared x. There's your Pythagorean identity again. Plus cosine of x plus 1 equals 0. Get negative cosine squared x. Combine your like terms. We can let u again equal cosine x. Just make our life easier. So we get negative u squared plus plus u plus 2 equals 0. And now I would divide everything by negative 1 to change the sign, so it's easier to factor. So u squared minus u minus 2 equals 0. U minus 2, u plus 1. So u will equal 2, u will equal negative 1. We're not solving for u, we're solving for cosine. So cosine is 2 and cosine is negative 1. This one doesn't work because it's bigger than 1. And for this guy, only one place where x is negative 1, that's at pi. That's C, and let's look at D. We have 2 sine x cosine x equals negative sine x. Now on this one, some of you might want to think of this as a double angle, which it is. Sine of 2x equals negative sine of x. But that doesn't seem to help us anymore because we can't combine those two, so that's not the best idea. Instead, we're going to want to move the negative sine x to the other side, and you'll see why in a sec. So we get 2 sine x, cosine x, and if we add it, we get plus sine x equals 0. Everything's set equal to 0. Now you can see that there's a GCF, sine of x, in each term. Pull it out. We have 2 cosine of x plus 1 equals 0 left over, and now you have 2 terms. If each of them are set equal to 0, we can solve now, because that will make the whole thing 0. And we get sine of x equals 0. Where's your x coordinate? 0. 2 places, 0, pi, and pi. And this will be cosine of x equals negative 1/2. Where is x negative 1? Or where's my x coordinate negative 1/2 at 2 pi over 3 and 4 pi over 3. And again, no domain on that. So that's 15. I hope that helps with 15.